G'day, Mr. Crawford here. Going to talk to you a little bit now about heat. Now, we use heat all the time. It's a part of the universe around us. For example, in the oven here right now, we've got some pizzas that some of the students are making. They're actually making that using heat. They're using the heat to cook the food, to melt the cheese. But what is heat? Exactly how does it work? I mean, that's pretty important if you're going to use it. You actually have to know what heat is, and that's what this video is going to be all about. What is heat and how does it work?
So, what is heat? Well, in its simplest explanation, heat is energy. But what's energy? Well, again, going for the simplest explanation, energy is the stuff that you need to make things happen. Think about, well, you. If you're just sitting around at home, not moving, just sitting there on the couch, vegging out, you're not using a lot of energy. On the other hand, if you get up and you start walking around, you're using more energy. And if you're running around, well, you're using more energy still. Molecules, like water molecules, for example, are pretty much the same. If they're just sitting still in a solid, where they're not moving around at all, they're keeping the same position, they're not using much energy. We say that a solid is a low energy state because the molecules aren't moving around. On the other hand, if you've got a liquid like water, which in some of the other videos we've shown has the molecules actually moving around each other, that's a bit like you getting up and walking around. You need more energy to do it. And if we boil the water and we turn it into a gas and it flies up into the atmosphere, well, that's just like you running around. The molecules are really active. They've got a lot of energy. Now, we've also shown that we can move energy backwards and forwards between different things. So I took a cup of water like this, and I took some alfoil and put some dry ice in it, dry ice being very cold, very, very cold. So it sucks up all of the energy around it as fast as it can gobble it up. Put that into a cup of water, and look what's happened. The water that was around the outside has changed from a liquid to a solid. It has lost energy. So now those molecules are just sitting there. Now, of course, you know and I know that you can add heat to a solid without it changing into a liquid. For example, this oven pan, like the one that I was showing you in the oven just before that had the pizzas on it. If I put this oven pan into the oven and I turn the oven up really high and I leave this metal pan in there for, say, half an hour, the reason that happens is because the pan, even though it is still a solid, has absorbed some of the heat, has absorbed some of the energy. So how does that work? Well, think of it this way. My daughter, Gwen, sitting at home, she's just sitting there on her chair. But after a while, she can't just sit there completely still. She starts squirming around. Now, the reason she's squirming around is because she's got too much energy to sit still. She doesn't want to get up and run around, but she can't sit perfectly still. So she starts to squirm or fidget. Now, molecules behave exactly like my little girl, Gwen. If you give them enough energy, they might start squirming around. They might start fidgeting. We don't actually call it squirming or fidgeting in science because it doesn't sound sciencey. What we do say is that they're vibrating backwards and forwards. And we, as human beings, perceive that vibration as heat. It's just the molecules fidgeting. If you add even more energy to those molecules, of course, they start moving around, like my son, Alexander. Yep, there he goes. He's got too much energy now to sit still. So instead of just sitting there vibrating in the one spot, he actually starts moving around. Molecules behave exactly the same way. If you put too much energy in, they don't just vibrate, They get up and they start going in all sorts of directions. That can change them into a liquid, and if they're going really nuts, it changes them into a gas. Cold, coldness. What is coldness? There's no such thing. I know. There's actually no such thing as coldness. What we as humans think of as being cold simply means that when we touch it, we have more energy than the thing we're touching. It might be ice, it might be the air coming out of the air conditioner, it might be a cup of water. But coldness is not a thing. Heat is actually what we're measuring. Heat is actually what we're perceiving. Differences in heat. You can't put coldness into something because it doesn't exist. All you're actually doing is moving heat from one place to the other. If something has less heat than something else, then the something that has less heat is colder. If you have more heat than the cup that you pick up, then you think that the cup is cold because energy is, even as we speak, traveling into your hand, like this ice. If I grab onto the ice, it feels cold, really cold, so cold that it's actually hurting my hand because I'm losing energy so fast and it is going into the ice. The ice is stealing all the heat out of my hand, and man, that really hurts. Ow! Coldness is not a thing. It's all about heat. No coldness.